This UCSD TV program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest programs. The Sam and Rose Stein Institute for Research on Aging is committed to advancing lifelong health and well-being through research, professional training, patient care, and community service. As a nonprofit organization at the University of California San Diego School of Medicine, our research and educational outreach activities are made possible by the generosity of private donors. It is our vision that successful aging will be an achievable goal for everyone. To learn more, please visit our website at aging.ucsd.edu.
Well, thank you very much, and thank you for coming. And let me go ahead and get started. And what I'm going to talk about is really two topics. One is, which are kind of opposite disorders in a way. One is obesity, and the other is anorexia nervosa. And there's a lot of different ways that we could compare them, but I'm just going to talk mainly about two areas. One is reward and inhibition, and those are brain functions, and the other is energy metabolism, and a little bit about cause and consequence, and then follow it up a little bit about what we know about treatment and what we're doing at UCSD in terms of unique treatment approaches. So I just want to start by thanking many of the collaborators. I'm going to talk, the research I'm going to talk about for anorexia is going to be mainly our brain imaging research, and I wanted to thank the collaborators I've worked with, and particularly Ursula Baylor, who's in the audience here, who's been a key collaborator for many years on developing this line of evidence. So one of the very interesting differences between anorexia and obesity is weight loss. Now, on your right side, you'll see kind of a typical representative study of a weight loss in people that are obese. So these were women that were roughly about 200 pounds, and they got put on several different kind of comparison diets. One was just a diet, one was behavioral therapy, one was a combination. Didn't really make much difference. And what you see is, about what you typically kind of see in this with obesity is about a 10 or 15% weight loss. It seems good, except if you follow these people out long enough, which is what they did here over 5 years, you'll see the recidivism rate is really high. So it's very hard for people to stay on a diet. And we'll talk about that. Now, in contrast, one of the very unique problems with people with anorexia is this is probably the only group of people of which I'm aware that can literally starve themselves to death. And so if you had anorexia, you would be somebody that would want to eat 300, 500, maybe 1,000 calories a day, every day. And you could get down to a very low body weight, and that would be fine with you. And while people, and we'll talk a little bit about this, have thought of this as a cultural or psychosocial disorder, we're beginning to find there's a very powerful biology that's contributing to it. And I would challenge anybody in this audience to eat 500 calories a day for the next 10 years. I mean, if you didn't have anorexia, people would find that pretty much impossible. At some point, homeostatic mechanisms, which we'll talk about, would kick in and literally kind of drive you to eat more food, and that does not happen with anorexia. So it's easy to kind of talk about the treatments for these disorders because we don't really have effective treatments. Obesity, whether you use medications or various kinds of behavioral psychological therapies, it best results in usually a 10 to 15% weight loss, and there's this very high recidivism. Whereas anorexia, we actually have no drugs and no proven therapies that diminish core symptoms that people with anorexia have. And because of this, there's a substantial chronicity of these disorders and actually the highest death rate of any psychiatric illness. People literally starve themselves to death. So you're probably aware that when you're thinking about food and weight maintenance, it's a very simple kind of calculation. Calories in have to equal calories out. So calories in are food and beverages you eat and drink, and calories out are how that energy gets used to sustain body functions as well as physical activity. Now, there's a lot of different ways to think about obesity and anorexia, and I'm not going to portray the only ways because there's a lot of theories and a lot of data in this field, but I'm going to talk about really only two components. One is reward and inhibition and how people manage food homeostasis, eating behaviors, and the other one is a little bit about energy efficiency, because I think there's a lot of data that suggests that these are key components for both disorders. So when you're thinking about food and appetite, there's a lot of systems to look at. And for either anorexia or obesity, there's a lot of questions. I mean, where is the locus of the disturbance? What might actually be causing this? Is it peripherally? Is it in the gut? Is it in the hormone systems that get secreted in relationship to food, like insulin or leptin? Is it nerves that innervate the GI tract? Is it metabolism of the body, or is there something going on in the brain? Now, understanding what goes on in the brain has actually been very difficult for us as in psychiatry and neuroscience, because we haven't had good tools that allow us to look inside the brain of living human beings until maybe the last 10 years or so, when we've developed some very powerful brain imaging tools that allow us to actually start to ask questions about how the brain works in relationship to behavior. So this is relatively new information. And one of the things that's been discovered in the last decade or so is that what we've known, that there are areas of the brain, particularly in the hypothalamus. So the energy balance there is pointing to the hypothalamus, which is very low primitive part of the brain that's very important for energy balance, and it works with the body and the periphery and hormone signals to really kind of understand how hungry we are and how much and drive food intake. But above and beyond that, at a higher center of the brain, there are systems now that we understand that contribute to the pleasure and motivation that food gives us, and also other cognitive systems that allow us to kind of control and inhibit our appetite. And I'm going to really talk about these higher systems today. If you look at BMI, which is a measure of height and weight, and you can see there 18.5 to about 25 is a normal BMI. If you ask the question, how many people are obese in the country, what you see is this really remarkable increase over 20 to 30 years, where relatively in 1990, relatively a smaller percent of the population was obese, and now the last time this was done in 2010, you could see, many states have 30% or more of people that are obese by these criteria. So this is a relatively recent phenomenon. And the same thing is true for children and adolescents. There's been an increase in obesity in various age ranges of children and adolescents over the last 3-4 decades. Now, it's taken us millions of years to evolve to become human beings. And here you have a phenomena that's all of a sudden occurred in a relatively short period of time. So the question is, what's changed, or how is the body responding to what in the environment that's creating this obesity in the last couple of decades? Clearly, it can't be genes, because genes don't change in 27 years, but actually genes probably do play some role, and we'll talk a little about that. So the factors that are really kind of thought to contribute to this are kind of complex, and it's probably an interaction of genetics that make people susceptible, either in terms of metabolism, energy balance, the amount of energy that we use to keep our cells alive and create physical, and get burned off when we do physical activity, as well as the genetics that contribute to appetite regulation, as well as the changes that are going on in the environment in terms of not only a more sedentary lifestyle, but access to highly palatable fast food in very large portions. So just as an example here is how much larger things like slices of pizza or bottles of Coke have become in the last couple of decades. And then the question is this really driving our this overweight, or is there something about human behavior that makes us susceptible to this kind of highly palatable fast food? And that's, probably that's the thesis that I want to talk about. Now, in terms of anorexia, because you probably have somewhat less familiarity with anorexia, this is a disorder that's puzzled people for many, many years. It tends to be a relatively narrow range of people. It tends to have an occurrence in adolescence, particularly it's mostly female, and it's relatively uncommon. Less than 1% of girls have anorexia nervosa. And this is a group that develops really severe restricted eating and becomes very emaciated, can lose 30, 40 pounds. Along with that, they have body image distortions. They fear being fat. They fear eating fat. They look at themselves and see themselves as being overweight, even though they're emaciated. Even though they diet, they're preoccupied with food. They think about it all the time. They cook for others. And the thing that makes it so hard to treat this disorder is we're not really on the same team. People with anorexia don't tend to see themselves have a problem. They don't want treatment. And often, to get them into treatment, you really have to force them in there because literally they don't see themselves as being thin and emaciated, even though it's, of course, terrifying their family. Now, in the long run, but that's 5 to 10 years, a majority of people with anorexia either recover or have a pretty good outcome, at least a partial outcome. But still, it's got a very high death rate. And people will literally starve themselves to death if you don't force them into treatment and force them to eat and gain weight. So, many people diet in this culture. I would guess everybody in this audience has had an episode of dieting. Probably nobody here ever developed anorexia. I don't know. Or bulimia nervosa, which is the other eating disorder that we treat. So the question is, are there susceptibility factors that put people at risk for developing an eating disorder? Why are some people vulnerable to this and lose weight, whereas most of us will diet and then, actually gain the weight back? So we actually have a new understanding of eating disorders. For one thing, eating disorders run in families. If you have anorexia, you have a much higher chance of having anorexia or bulimia nervosa in your family. But that doesn't really tell you if it's genes or it's parenting. But there is a way to tease that apart, and that's to look at identical and non-identical twins. And without going into details, if you do that, what has been found over and over again is that heredity is actually more powerful than environment. And heredity contributes somewhere between 50 to 70 to 80% of the reasons why people develop an eating disorder. Now, genes don't actually knock out some center of the brain and cause anorexia. What we think is genes contribute to some vulnerabilities that actually exist in childhood that makes people susceptible to developing an eating disorder. And so if you talk to a group of girls with anorexia, you'll find that most of the time they tend to be, as children, now people develop anorexia usually around early teenage years, around puberty. But as children, when they're 6, 8, 10 years old, these are perfectionistic, achievement-oriented, kind of anxious, shy kids who really have a drive for achievement. They almost always get all A's. So that seems to be some of the susceptibility for these disorders. So there is this powerful neurobiology. So to just kind of put it in perspective, we think in childhood there are these temperament traits that exist in childhood Negative emotion, we meet anxiety, particularly in depression, and they're also kind of obsessive. But these are good little kids. They don't really give parents trouble. They're achieving, they're compliant, they're doing well in school. And then something happens during puberty, early adolescence, and they tend to get more anxious. And whether it's puberty, the hormones are related to puberty, or changes in brain development, or stress or cultural factors that interact, and probably it's more likely some combination of those, people start to go on a diet. And they develop weight loss, and they kind of cycle out of control. The more weight they lose, the more weight they want to lose, and they just cycle, spin out of control, and often will die if you don't intervene. And so one of the things that we've learned about these disorders is, as opposed to what happens with you and I, and I'll talk more about this, where if you and I don't eat, we get kind of uncomfortable, irritable, tense, we don't feel good. People with anorexia describe kind of the opposite kind of phenomena. They tell you that they're anxious all the time, and when they don't eat, they feel better. Kind of makes them feel more comfortable. So there's no wonder they don't eat, because, eating actually drives anxiety. So what about reward and inhibition? Now, one of the first things you need to know is that the way we've been describing behavior for a century or more in psychiatry is getting to be kind of old-fashioned. And that is that the way we describe disorders like anorexia or depression or anxiety is it's a kind of a cluster of symptoms that fall together in people. People that have anxiety or depression kind of have a group of symptoms that are somewhat similar, but usually there's a lot of variance. There are no brain centers that you can knock out that will cause something like depression or anxiety or anorexia. It's really much more complicated than that. And we're developing a new understanding of how behavior is encoded in the brain and how to label it and how to describe it. And some of what I'm going to talk about today is kind of this new developments in trying to describe how behavior is encoded in the brain and what's different about these circuits in people with eating disorders. So just to give you an example, psychiatry is really where we were about 100 years ago with medicine. So if you came into the doctor 100 years ago and you're coughing, and they would ask you what you're coughing up, is it yellow, is it white, is it red? And they might try and diagnose you on the color of your cough. Now, we know that now that whatever you cough up, if it's red, it might have some blood in it. If it's white and clear, it might just be fluid. If it's yellow, it might have some red blood cells. That really is a response to whatever's going on in your lungs. It's not really, necessarily related to the etiology. And now we have ways of really teasing apart the etiology and to determine whether it's bacterial or viral or TB or whatever. And we have more specific treatments now based on the etiology, and we can do a pretty good job of treating these kind of things. But we're just starting on the edge now of being able to kind of describe the way behavior is encoded in the brain. And I think that will actually lead to a better understanding and better treatments of psychiatric disorders. So I'm going to talk really about the cognitive control and pleasures motivation of appetite. And how does this kind of how do we experience this? Well, for one thing, these higher centers can override these lower centers in the hypothalamus that control energy balance. And how do we know that? Well, we know that even though the obese have sufficient energy stores on board, they still overeat. And people with anorexia nervosa restrict their eating even though they're emaciated. So they override these hypothalamic signals that are out there screaming, you gotta eat, and they don't do that. Now, what about all of us? Well, suppose you go without eating for a day or two. How do you feel? Not only might you feel kind of irritable and tense, but you might think about food, and that first bite of food after you go without eating actually usually tastes pretty pleasurable, more pleasurable than usual. And you keep eating food, and it still may be pleasurable, but it's not as pleasurable as when you're really hungry. And the same thing happens with water. It just happens in kind of a more rapid time course. If you don't drink water for a day or two, you get very thirsty, and that first sip of water tastes very pleasurable. So the brain has ways, responds to hunger by increasing the reward, and which in turn increases the motivation to seek out food and water and other salient stimuli. And of course, that really makes sense. We share these processes with animals. If you're an animal out there living in the wild and you're a rabbit and you're sitting out there in your den, the world's a dangerous place, you start to get hungrier and hungrier, that's going to motivate you to go out and seek food. We also habituate to food. So you have this, you experience this at dinner. You'll eat a certain amount of one food and you kind of get tired of it and you move on to another food. So just as food, it can be rewarding, it can be gradually satiating over time, and we habituate to it. And food can actually be aversive. So if you eat a small piece of chocolate cake for dessert, it might taste great. Somebody forces you to eat that whole chocolate cake, that pleasure would soon turn to disgust. These parts of the brain really encode these emotional messages about food, which are very important for shaping driving our behaviors. So a very simplistic kind of model here is that what the brain does is it helps us kind of balance the reward and the immediate gratification of food, as well as thinking about the long-term kind of consequences and inhibiting our behavior if that's what we want to do. Now, as it turns out, the circuits that are very important for regulating food are very important for regulating other what we call salient stimuli that we respond to, things like drugs and money. So that these circuits respond in a similar kind of way to other kinds of salient stimuli. And some people have problems with being very impulsive about money or overusing drugs, and I'll go more into that. So one of the points I'm going to make here is that what we're thinking is that there may be an imbalance between reward and inhibition, particularly in some people with obesity. And, why might this occur? Well, our ancestors didn't really have the luxury of having a supermarket in every shopping mall that we could go into 24 hours a day. Food was scarce, and getting a meal was kind of, very, very important. You wanted to eat as much as you could, and that's true for animals too. So it makes sense that the brain would actually be skewed in such a way that it would drive the reward and the pleasure of food. And there may have been relatively less need for inhibitory self-control because it was really the environment that was really providing the self-control. And as I just mentioned, drugs of abuse are thought to really hijack these same neural circuits, and palatable foods engage the same reward circuits. But one of the problems is you can live in an environment without drugs, and you can be abstinent, but you can't live in an environment without food. So the question is, will the understanding of some of these mechanisms start to lead to more effective kinds of treatments? So let me just talk a little bit about what we know about how the brain works. I'm just going to do this in 2 slides. It's a little bit more complicated. But the reason I'm going to talk about this is if you want to start to understand why people with anorexia or bulimia or obesity act the way they do, it's not that there's some center in their brain has been knocked out that creates this kind of aberrant kind of behavior. It may be that the neural circuits that we use to process information and strategize behaviors may be skewed in such a way in both obesity and anorexia that make them act the way that they act. So it's very important to have some understanding of how the brain normally kind of works. So what the brain does, it's really the organ that interacts with the world and develops strategies to meet our needs like food and stay alive. And so what the brain does is it's got ways of determining what the external needs are out in the world as well as our internal needs like hunger or satiety. And it identifies, as we process stimuli out there in the world, we're constantly looking at it and kind of thinking, even at this unconscious level, is this good for us? Is this bad for us? Do we like this? Do we not like this? What's the significance of that stimuli? And we generate some kind of response. And so we also weigh the short and the long-term pros and cons of this response. and we can decide to either inhibit our response or carry out some motor activity to accomplish whatever the goal is. And also what we do is we learn from that. We verify and learn from the success or the failure, whether it's rewarding or aversive. And the next time we encounter that stimuli, we want to do a better job of that. We want to anticipate what the stimuli is, or what the risk might be, or what the reward might be the next time, and learn from our behavior so we can do that more efficiently and the more accurately and appropriately we can make these decisions, the more competitive, especially if you're an animal, you are, and that's going to ensure your survival. So the way we do that is that there's a series of what we call corticostriatal loops. These are loops between the cortex, which is the upper part of the brain, which makes us uniquely human, and lower parts of the brain, like the thalamus and the basal ganglia, which is also called the striatum here, and that helps us process information. And there's a limbic loop that we use kind of first to really understand what the emotional significance of some stimuli is in the environment, and it produces some emotion in response to that. So it kind of helps us deal with kind of emotion and the here and now. And this part of the brain that thinks about consequences and can inhibit our behavior is called either the cognitive or associative executive circuitry. We often give the same systems different names just to confuse people. And that responds more to the effortly regulating of these resulting kind of emotional states. And it's the part of the brain that thinks about plans and consequences and can inhibit our behavior. And then as a kind of a sum of those two systems, then we carry out some motor activity to either do something or we don't, or we inhibit that motor activity. Very simple model of how the brain works. So what are we learning about people with eating disorders? And how do we use this? So just to give you kind of an example, if you go to Las Vegas and you're playing blackjack, so the dealer might get a 10 and you get a 9 or a 19. Now, for those of you who play blackjack, you know that if you stay on the 9, you're going to lose and even at the 19 you might lose because there's a good chance the dealer has a 20, so that you have to make a decision whether you're going to bet or not and try and get closer. Now, so how do you do this? Your brain uses these systems, assess the risk versus reward. You look at your cards, the dealer cards, how much are on the pot, how much you can afford to lose, and bet or fold. Now, people have different temperaments. Some people are very over-responsive to rewards or don't do a good job in inhibiting, and they're much more likely to bet. And people like this, I'm sure. And this increases the odds that they're going to lose because, they're just not going to consider the risks. And you have other people that have a temperament to overestimate risk and be very, very kind of cautious about betting, and they may not lose, but they're not going to win very much either. So people have different temperaments, and these tend to be kind of lifelong temperaments. And it may be that people with obesity and anorexia have certain kind of temperaments like this that make them susceptible to eating the way they do. So another way kind of looking at this, if you look at these kind of systems, the hypothalamus, which is where the energy balance is kind of summated from signals coming into the periphery about just how much energy you have stored, and the limbic system, which is important for kind of emotion and the pleasure and reward of food, and the dorsal, the cognitive or associative system that kind of thinks about the ability to favor alternatives to eating or inhibit your behavior. Together, these kind of make up a message about food consumption. So there actually is evidence that people with addictive behaviors as well as people with obesity may have disturbances in either enhanced reward or diminished inhibition. So people with addictive behaviors, they tend to prefer immediate over deferred rewards. Even if the deferred rewards are a larger value, they want it, they rather have something smaller now. And they're also often impulsive or lacking in self-control. And similarly, some of the obese are more impulsive or have decision-making deficits. Some prefer sooner rather than later. And it's been thought that people who do a better job of dieting may have more powerful cognitive control systems and better able to kind of inhibit their behaviors. Now, this hasn't been certainly found in everybody with obesity, but there is evidence that suggests at least some portion of people with obesity, these are contributing kinds of factors. So what's different about anorexia? Is there a diminished reward of eating or some enhanced inhibition or self-control? There is some controversy in the field at this point about whether obesity is due to some predisposing risk factors that people are born with, or the other question is this kind of just the consequences of prolonged pathologic eating? Once you start to overeat, does this produce addictive kind of like behaviors in the sense that it somehow you get into kind of a vicious kind of cycle that gets out of control? And there actually is some evidence suggesting that extremes of food do actually change, have kind of an addictive kind of like phenomena, that in terms of reward pathways, overconsumption tends to desensitize and underconsumption tends to sensitize reward pathways. But there actually is evidence suggesting that if you're an adolescent and you're at risk for obesity because you have family history of obesity, you may be somebody that has increased susceptibility, increased reward response to food, and that actually may change with time as you become overweight. And it's not so much that it's the reward, it's the anticipation of the reward that actually may get activated that may drive overeating behaviors. And so the question is, it's really been unclear in the literature whether the obese are people that are kind of oversusceptible to rewards, or they have a reward deficit and they're overeating to get the same kind of rewarding feeling. Stay tuned. So just to kind of give you a kind of a model here, this is a model that would suggest at least some people with obesity have increased reward activation and decreased ability to inhibit their behaviors. But this is a very heterogeneous disorder, and by that it's very, very likely that there is not one cause of obesity. There's many different contributing factors, and these are just some of the factors that contribute in some people. Still a story that remains to be determined. Now, what about anorexia? Well, as I've mentioned, people with anorexia are very different than most people who have a rewarding response to food, especially as you get more hungry. And people with anorexia have this very unusual, unique response to food, whereas when they eat, they feel anxious, and there's something about that, not eating that makes that anxiety not go away, but at least diminish. So one thing that we know about people with anorexia are the stimuli that appeal to most adolescents, food, drugs, sex, rock and roll, are not really of much interest to people with anorexia. This is a group of people that really worry about things. They worry about consequences. They want to do things right. They don't like to make mistakes. They're very inhibited. They're overly controlled. And there's a lot of data that supports this behaviorally, that we know that people with anorexia, especially when they're underweight, are anhedotic. There's very little in life that's rewarding to them, and they're insensitive to reward. People with anorexia can delay gratification. They'd prefer to have a larger reward later. Most people don't do that. And they're harm avoidant, they're risk avoidant, they're very sensitive to criticism, what we call punishment, that's aversive, negative responses to things, people being critical or just the appearance of being critical or doing things wrong. So we actually now have imaging results that support this. And without going into a lot of detail, let me just describe some of the things that we see. So dopamine is a very important neurotransmitter in the part of the striatum that's very important for reward, particularly in the area called the nucleus accumbens. And dopamine is an important signal for reward. And we find, our group and others have found that there are disturbances of dopamine, particularly in this part of the brain in people with anorexia, suggesting that this reward center doesn't work right. And when we've done studies where we ask people with anorexia to distinguish reward and we look at how their brain distinguishes winning some money versus losing some money. People that don't have anorexia have a much stronger signal to winning than to losing, just not surprising because people are more sensitive to reward. People with anorexia have a hard time distinguishing winning and losing. They have pretty much the same signal to both. So that suggests that the limbic system, this system for immediate reward, just isn't working the way it should. And the system, the cognitive system that responds to long-term kind of consequences, looks like it's overactive. It's overactive in response to making choices. The more anxious people are, the more harm avoidant, the more risk avoidant they are, the more activity they have in the circuit. And as opposed to most people who are more sensitive to winning than losing, we see people with anorexia actually are much more sensitive to losing than they are to winning, and it's particularly in this part of the brain. So what we think is going on is that the reward part of the brain just isn't working very well. It just doesn't actually probably encode reward well, and people with anorexia have kind of increased traffic and increased activity going on in this part of the brain that worries about what's going to happen, worries about consequences, and they can't turn it off. It's on all the time. They're just thinking, something's going to go wrong, I'm going to make a mistake, and it's a very unpleasant way to go through life. Now, there actually are some animal studies that suggest this. If you're a rat and you're a risk-avoidant rat and you give a rat some choice getting some food, but you make it a bit risky, the rats that are really risk-avoidant have exactly the same kind of overactivity of the same part of the brain as people with anorexia. And in humans who have reduced inhibition, they have reduced activity of the same part of the brain. So this suggests actually there really is a biology contributing to this. So Dr. Baylor and I did a very interesting kind of experiment that kind of was a proof of concept here. So we had these two systems, the limbic system and the cognitive system that I told you about, and we gave people one single dose of amphetamine. Now, what amphetamine does is it releases a lot of dopamine in the brain. And we can measure how much dopamine is released by when we give amphetamine. And we know when we found the same kind of things that if you're a healthy control, amphetamine tends to make people feel good. It makes them euphoric. And we found that the more dopamine that was released in this part of the ventral striatum, this limbic system, the nucleus accumbens area, the more euphoric they are. And that's been shown over and over again. So the more dopamine, the more euphoric people get. Very nice kind of signal there. That's not what we saw in anorexics. What we saw is that the dopamine they released in this part of the brain that worries about things actually was correlated with anxiety. The more dopamine they released, the more anxious they were. Now, you release a little bit of dopamine when you eat food as part of the whole system that kind of responds to the rewarding aspects of food. So eating or anticipating eating releases dopamine. If you're somebody with anorexia and when you release dopamine, it makes you anxious rather than it's rewarding, it makes a lot of sense that you're not going to eat. And, people don't like to be anxious. It's actually wired into your brain in such a way that it gets your attention. And you get anxious enough that it's all you can really kind of pay attention to. And so, in some levels it makes sense not to eat because, it's such an unpleasant kind of feeling, and who cares about the long term if you're feeling anxious right now and you have some way of making this go away. So we think there's this altered balance in people with anorexia nervosa, and they have difficulty evaluating reward. And actually, we have other studies now suggesting that the more anxious they are, the less responsive they are to reward in this part of the brain. And food is not rewarding. Food produces anxiety, where these are people that are oversensitive to risk and error. And in this part of the brain, the more anxiety they have, the more oversensitivity we see in terms of response to risk. And as I mentioned, there's this anxiety-reducing character to dietary restraint. So why does this make sense? Does it make sense to you at all? Well, if you're a rabbit living out there in the wild, your job is to either, find food and avoid becoming food yourself. And so food is rewarding, but there's a risk to gathering food. And, I don't think we've kind of paid much attention to it because there's very little risk for us as human beings now to gather food, to eat food. But for animals in the wild, there clearly is a risk. And so you're going to approach food, but you're going to avoid risk. If you're a rabbit that overestimates reward and doesn't consider risk, what's going to happen is you're probably going to get eaten by a fox and you're going to be out of the gene pool. And you're not going to pass on those genes, and so simply you're not going to pass on that kind of behavior. If you're a rabbit that overestimates risk, you can go without eating a couple of meals in a risky situation. You're not, if you're a rabbit, you're not going to die from it, but you're going to decrease your odds of becoming lunch for the fox, and those are genes to pass on. So what I think is going on with people with anorexia is they have this kind of trait, this temperament for harm avoidance, risk avoidance, anxiety, inhibition, and flexibility. Food generates a risk signal, not reward. Not eating reduces this aversive emotion. So this little reward drive to eat and enhance ability to inhibit eating. So, ancestors lived in a dangerous world. And I look at this as kind of an alarm detector kind of system. It's a temperament bias where risk outweighs reward. And this system seems to be just turned on in people with anorexia. If you were living 50,000 years ago and you're sitting around the tribe, it would be very beneficial to have a couple of people that had these traits. Maybe you wouldn't want everybody in the tribe to be kind of this way. It would be kind of unpleasant kind of situation, everybody worrying about things. But it would actually be a good idea to have a couple of people sitting around the tribe worrying about what might happen. And this is the people that have a repertoire of alternative plans if something goes wrong. They're persistent. They pay attention to detail. They don't do well with change and uncertainty. And nature doesn't really care if you're happy. Nature really cares that you stay alive and you pass your genes on. And these are people that can't really turn it off. It's on all the time. And what the things they do, they're good students. They like to go to school. They exercise. And those are the reason they do that is those are probably diversions. Instead of this circuit just being on all the time, you give it something to do, and they're less anxious. Now, the thing that's really key about it is that when people recover from an eating disorder, they tend to do really well in life. These traits that get them in trouble actually can be very beneficial traits, and these are people that tend to pay attention to detail. They're very achievement-oriented. These are traits where people do well in things like engineering, medicine, research. I tell people all the time, I've never had an eating disorder, but I'm kind of obsessive and perfectionistic. I can tell you, it's very hard to have a successful career in research if you aren't like that. It's just too competitive. So there is a competitive advantage in certain professions to be this way. And one of the things that we're trying to do now in our program is trying to understand the beneficial aspect of some of these temperament traits so that we can get people with anorexia to begin to learn how to use them in constructive kind of ways rather than destructive kind of ways. So what about energy and efficiency? That's the other thing I want to talk about a little. So this is a study that I've presented for so many years, I actually lost the reference to it. But it's a very interesting study. It's a study in rats. And let's see here. So what happened is this is a natural growth curve for rats. So this is the body weight, and this is some period of time. So this is the control, and if you just when rats are young, just like us, as they get older, their weight increases. And what they did here is they actually fed an experimental group of rats, I think roughly half of what they fed these rats. And what happened, of course, is these rats, lost some weight and then kind of stabilized here. But what they did here is they pair-fed these rats just the same as these rats, and not more food, just pair-fed them. And look what happens. The rats have a way of changing their energy use so that they got right back on the growth curve. And unfortunately, this is the kind of model of what happens when people lose weight and they're obese, is there's something changes about their energy balance so that often they're able to gain weight much more easily than they ought to. So there seems to be two things that happen when people lose weight. And these are studies that have been done in the obese. And the brain's response to food when you lose weight, you lose 10, 15% of your body weight, and your brain changes in response to food. The parts of the brain that respond to reward get more active, and the parts of your brain that kind of inhibit eating get decreased. And what happens is that people that have lost weight then start to have more food cravings, particularly for calorie-dense kinds of food, and they even have decreased perception of how much they're eaten, so that they eat more. The other thing that happens when people lose weight is that there's a change in their energy expenditure. They actually become more energy efficient. And there's been studies, for example, looking at the obese that lose weight and feed them the same amount as a group of people that were just their usual weight, and the obese people just fed no more calories than the normal weight kind of people, gain weight easily. So two things really happen when you lose weight and you're obese, and that is food becomes more rewarding and you become more energy efficient. And that probably accounts for why people, there's this high recidivism rate. So evolution, what it really says is evolution really favors the defense of body fatness over body thinness. And of course, that really kind of makes sense that, if you're an animal living out there in the wild, you want to have your homeostatic system skewed in such a way that you're going to eat and overeat when you have meals available, or if you lose weight, you're going to become more energy efficient so that you can survive on less food. Now, there actually have been some there's a registry of 4,000 individuals who have maintained a 30-pound weight loss for about a year, and there's some strategies that they've used to maintain that weight loss. I think the mean was about 4 or 5 years. And this isn't kind of rocket science. It kind of makes sense. These are people that ate a low-calorie diet, particularly low-fat diet, with minimal variance. They kind of ate the same thing every day. They ate breakfast daily so they didn't get overly hungry. They frequently self-monitored how much they weighed and the caloric intake. They got regular exercise, and they limited TV viewing. I mean, this probably is no surprise to you that these are kind of strategies that are going to help you maintain weight. It's just that most people really aren't able to kind of maintain this kind of rigorous, while it seems simple, it's still a very rigorous thing to do. There is one relatively successful treatment for obesity, and that's bariatric surgery. The purpose of this talk isn't really to go into that in detail. It's a talk of itself, but there's different kinds of ways of reducing the size of the stomach or diverting the stomach contents. They work some work better than others, but this has certainly been a very successful treatment, probably the only successful treatment for obesity, but of course it involves surgery. Now, for anorexia nervosa, we see kind of an opposite kind of pattern. So this is I think the best way to illustrate this is just to show you a typical course of somebody with anorexia. Now, this was actually done probably about 20, 30 years ago when I was at NIH and I ran the program there. And I say that because insurance doesn't allow us to keep people with anorexia in the hospital, for 8 months now to get them up to a healthy body weight for the most part. So this is a person that came in the hospital. She was about 70% body weight, and this is her percent body weight. And gradually over the course of these many months, she got up to about 95, a little bit more than 95% body weight. Healthy women need about 30, this is calories per kilogram. So if you're 50 kilograms, that's about 110 pounds, and people need about 30 calories per kilogram to maintain their weight. So you need about 1,500 calories a day if you weigh about 110 pounds, with a range of around 1,000 to 2,000. So this is where normal controls would be, right about 30. If you start people with anorexia off about 30, or you start to increase a little bit, what happens is they start to gain weight and then they plateau. And they stop gaining weight. And you have to keep increasing their calories to get them to gain 2 or 3 pounds a week. And the amount you increase it can be very high. We got this person up to about 70 to 80 calories per kilogram a day. Now this is about 4,000 or 5,000 calories a day for that person, equivalent to me eating 8,000 calories a day. I can tell you it'd be hard enough to eat 5,000 calories a day every day for 6 months here or so, and even harder to eat 8,000. So this is a group of people that want to eat 500 or 1,000 calories a day. No wonder it's hard to get people with anorexia to gain weight and recover, because you're forcing them to do something that's going to make them really, really uncomfortable. It's going to make anybody really uncomfortable. Now, so it takes roughly about 7,500 kilocalories, or about 3,500 calories to gain 7,500 calories to gain a kilogram, or about 3,500 calories to gain a pound of weight above and beyond what you need to just maintain your weight over this period of time. That's actually been very consistent for people with anorexia. And one of the interesting things that we found is that the more that people exercise, so these were activity monitors that they wore, these are just daily activity counts, the more they exercised, the more calories they needed to gain one pound. So actually the range was about 4,000 to 12,000 to gain just 1 pound. And so the high exercisers needed, almost 3 times as many calories to gain a pound as the low exercisers. And these are people that tend to relentlessly exercise. That's another contributing factor. But it wasn't the only contributing factor. And one of the things that we found that was very interesting is this is a 24-hour circadian temperature graph. So this is your body temperature in either Fahrenheit or centigrade. So here's 98.6 right here. This would be normal body temperature. And so this is when the person came in the hospital and they weighed about 31 kilograms, about 62% of their body weight in yellow here. And you can see that we've known this for a long time. People with anorexia have a low body temperature. That's one of the ways they conserve energy. They're just, not burning it off as heat. And when we started to refeed people with anorexia, and we got them up to 4,400 calories a day, which for this girl was almost 100 calories per kilogram per day, what happened is she, and we see this in other people with anorexia, had an elevated body temperature, and it was at night when she was asleep. And people with anorexia will often tell you that when they're overeating like this, they wake up in the middle of the night and they're sweaty and they're drenched, and they're burning these calories off as temperature rather than putting it on as tissue. So it's not just exercise. They just become very energy inefficient, just the opposite of obesity. The other thing that we found is that after people with anorexia get up to a healthy body weight and they're recovered, so I remember I told you controls need about 30 calories per kilogram. People with anorexia, particularly the restricting subtype, need a lot of calories just to maintain their weight for 6 months or so after they get to a healthy body weight. So we actually see differences between the anorexics who just restrict and the anorexics who also binge and purge. And this normalizes in the long term. If they remain recovered for 12 months or 18 months, then this does normalize. But they're hypermetabolic in the short term. Another reason, so they leave the hospital, they need more calories than they think they ought to need, and they lose weight very rapidly. So one of the things that you can think about anorexia is it's kind of a perfect storm. And that is, not only do you have reduced reward driving eating and increased abilities to inhibit your behavior, but you have some disturbance in energy metabolism, which makes you need more calories than you ought to need to gain that weight. So you put that together, reduced drive to eat, increased inhibition, and a lot of calories, and no wonder so many of these people die. So, it's very hard to change this behavior. In fact, we really have not discovered any way to do that. I can sit down and I do with the anorexics and their families, and I describe to them what I've described to you, and it's helpful for the families. It's not particularly helpful for people with anorexia because it doesn't really change anything. We do have a successful treatment now called Maudsley, or family-based treatment, and what that does is it actually brings the family in as allies. And we say to them, look, your kid really has a chronic disorder. She's liable to have this for 3, 5, 10 years. We can't, we can get her to a more healthy body weight, but she's going to go home and she's going to have the same symptoms. We're going to teach you how to understand and manage your daughter so you can at least get her to continue to eat and maintain her weight. This is actually much more successful than treatment, the old-fashioned kind of treatment like I showed you at the NIH, where we just got people up to healthy body weight and discharged them. Instead of having 75% or so people relapse, we now have 40 or 50% of people relapse a year after they leave. That doesn't sound great, but it's a lot better than it used to be. And a lot of our program for adolescents is structured on this, but not exclusively. And what we're really trying to do is come up with ways of modifying this behavior, whether it's medication or, as I've talked about a little, these developing more constructive coping strategies for this temperament. So what do I mean by that? For example, just to give you kind of a brief example, so this is a very anxious group of people. They have huge amounts of anticipatory anxiety. Just the thought of food makes them very anxious. And we're teaching people how to kind of understand that that's going to happen and ride the wave, or actually come up with ways of kind of diverting their attention and focusing on other kinds of things to deal with the anxiety. And there's other strategies too, just to give you some ideas. We also find that if we help to structure the environment, and this is why Maudsley probably works, we teach the parents how to limit choices, how to minimize uncertainty, how to structure meals so that the kids with anorexia can respond more effectively. And we also teach other things like contracting. We've known that people with anorexia don't respond very well to rewards. You can't kind of give them a new car to get them to gain weight and maintain the weight. It just doesn't seem to be very effective. They seem to respond more to consequences, and we're developing strategies to help them to make that more effective. So just to tell you a little bit about our program, we have kind of a new model of a program here. Instead of an inpatient or residential program, what we have is what we call a partial program. So this is a program that takes place in our offices up to 10 hours a day. It's somewhere between 3 and 10 hours a day, up to 6 days a week. And people, both adolescents and adults, live at home. And the reason that we do this is that we want people to still interact with the real world and their families and be able to use the skills that they've learned to learn how to cope with real world stresses and eating behaviors. We have two major programs. We have an adolescent program that's based on the family-based therapy, but we use other techniques also. And we have an adult program, and the adults tend to have more bulimia nervosa or other kinds of dysregulated eating disorder behaviors I'm not going to talk about today. So we have particular approaches aimed at that. And we also have a unique week for people that live too far away to come every day. We actually have a week-long intensive immersion in family-based kind of treatment that's pretty unique in the country. We also have a program at Rady Children's Hospital. We have a unit there for medical stability of people with anorexia nervosa, and also a weight gain program. And we've just started a pediatric partial eating disorder down there as we're beginning to see more younger and younger kids, 8 to 12 years old, and we think that they need a unique kind of program because they have different kinds of issues compared to adolescents or adults. So we have this program at Chancellor, we have the program at Rady's, and this is our phone number, our email, and also our website. But if you just Google UCSD, the eating disorder program, you will you'll get our program. We work with Carrie Boutel, who's the doctor here who runs the obesity program, which is focused on adults, adolescents, and children. And I just wanted to kind of mention that because if any of you are looking for a treatment, particularly for family members, as well as adults, you can contact the Center for Healthy Eating and Activity Research, which is called CHEER, and it consists of Dr. Boutel, who's a psychologist, as well as pediatricians and experts in exercise and nutrition, and they're also at UCSD and Rady's, and they have a program for overweight and obese children, a program for overweight and obese female adolescents, a program for overweight and obese adults, and so that there's several different programs and this is all outpatient treatment. And there's also some research going on there, and we work very closely together. And I also just kind of mentioned we're also looking for people who have recovered from anorexia and bulimia for our research studies. And so I think that's it. And thank you very much. We'll take some questions.